Hi sir, I am Madhu from CSC B section. Today I am going to discuss about the DQ operations with examples. Contents. Introduction to DQ operations, initializing a DQ, inserting element in a DQ, deleting elements from a DQ, peaking operations in a DQ, checking DQ empty or full status, example of DQ implementation using arrays, example of DQ implementation using linked list, and the conclusion. Introduction to DQ operations. DQ, also known as a double-ended queue, allow insertion and deletion of elements from both ends. It supports operations like inserting at front and back, deleting from front or back, picking at from front and back elements. DQ in C can be implemented using arrays or linked list. Initializing a DQ. To initialize a DQ in C, we need to allocate memory for the DQ structure. We can create a DQ structure with pointers to the front and rear elements. It's essential to set both pointers to null initially to indicate an empty DQ. We can see in the figure initializing and accessing structure members, not allowed and allowed. Inserting elements in a DQ. To insert an element at the front of the DQ, we need to allocate memory for a new node and update pointers accordingly. Similarly, to insert an element at the rear of the DQ, we follow a similar process of allocating memory and updating pointers. Inserting elements in a DQ can be done efficiently in 0 of 1 time complexity. Deleting elements from a DQ. Deleting an element from the front of the DQ involves updating pointers and freeing the memory of the node. Deleting an element from the rear of the DQ follows a similar process of updating pointers and freeing memory. Deletion operations in a DQ also have a time complexity of 0 of 1 due to direct access to the both ends. Peaking operations in a DQ. Peaking at the front element of the DQ involves accessing the values without removing it. Similarly, peaking at the rear end element of the DQ allows us to view the value without deleting it. Peaking operations are useful for retrieving elements with altering the DQ structure. Checking DQ element empty or full status. To check if a DQ is empty, we can verify if both front and rear points are null. Checking if a DQ is full depends on the implementation using arrays or linked list. In dynamic memory implementations, a full status may be determined by available memory consistency. Example of DQ implementation using arrays. Creating a DQ structure with an array, front, rear, and size variables. Implementation, insertion, and deletion operations considering wrapping around the array. Handle edge cases like full DQ, empty DQ, and raising the array dynamically. Example of DQ implementation using linked list. Define a node structure with data and next pointers for linked list implementation. Implement insertion and deletion operations by updating pointers of nodes accordingly. Utilize dynamic memory allocation for nodes and handle memory management carefully. We can see in the figure insertion how it be done. Conclusion. DQ operations in C offer a versatile data structure for managing elements at both ends efficiently. By using arrays or linked lists, developers can implement DQ with various functionalities. Understanding DQ operations and their implementation in C can enhance programming skills and data structure knowledge. Thank you.